So let's go ahead and take a look at example number 1 there. Example number 1 is really going to take a look at our abilities to understand that sum theorem. It's asking us to find angle C in the right triangle. So again, what's important here is that the angles of a triangle add up to make 180 degrees. Now what we see here in the bottom left corner of that triangle is that upside down L there. Remember that upside down L means 90 degrees. So even though that angle isn't marked, we know that in actuality it really means 90 degrees. We have this one down here that's marked 42, so we're saying 90 plus 42 plus our mystery angle C equals 180. And you can see they're kind of writing this again like we're solving an equation, which we're kind of getting used to now because we've spent so much time already this year solving equations, and here it is again. Well, 90 and 42 go together to make 132. So the equation simplifies to 132 plus C is 180. So when these two go together, they make 132, plus this mystery angle has to make 180. Solve the equation. Well, you know when we solve an equation, we always end up kicking all those numbers off to the right side of the equal sign. But remember, whenever I have to move something to the opposite side of the equal sign, here 132 is going from being on the left side of the equal sign to the right. When I do that, I do the opposite, which is why you see me subtracting 132. And indeed, here when I do that, I get 180 minus 132, which is 48 degrees. So my mystery angle here has to be 48 degrees. 48 plus 42 plus 90 does indeed make 180, and there is your triangle sum theorem. Let's continue on taking a look here at example 2. They're asking us to find the angle measures in the isosceles triangle this time. So remember, as I said in the introduction, when you have an isosceles triangle, you have two sides that are the same. And when you have two sides the same, you actually have two angles that are also the same. These angles are called the base angles. And even though they're not necessarily drawn at the bottom, that's still the name for them. The two sides here that look the same, should kind of look the same, would be these two here. Right? So there's your isosceles. That's how we see it. These two angles here. Notice that there are the angles that don't make up the angle formed by those two sides. Right? These two sides go together to make this angle. It's not that one. Right? It's the other two that match up. Right? Those two angles, all right, together make your 180 with the 62, and they have to be exactly the same, because when you have an isosceles triangle, two sides the same, you have two angles that are also the same. So here they go a little more two-step with the equation, and they say 2t plus 62 equals 180. Well, that makes good sense to us because we have two t's here, and if I add that to the 62, it's got to make 180. Solve the equation. Well, you know how to do that. Right? All my numbers have to get sent over to the right side of the equal sign, and we know that the thing that's directly connected to the variable with multiplication or division, in this case 2, is the thing that goes last. So send 62 over first, knock it off both sides by subtracting. So I'm going to end up subtracting 62 from both sides if I want to be really formal here, which is how I get 2t equals 118. And then chop out the 2 with division. Again, doing the opposite, sending all those numbers over to the right side. When I do 118 divided by 2, I get 59. And indeed, we can check it. 59 plus 59 plus 62. Does it make 180? Yes, it does make 180. So that's how we know we did this correctly. All right, let's go ahead and take a look at the next example, the last example before the check it out here. It says the second angle in a triangle is 6 times as large as the first, and the third angle is half as large as the second. And we're supposed to find the angle measures and draw a possible picture. Now, don't let the possible picture part scare you. Do the picture part last. There's nothing that says that the picture has to be drawn first. If you try and draw the picture first, you're probably going to drive yourself crazy because you're going to be labeling it all with things you don't really know anything about. So, let's go ahead and take a look at the key parts here. First sentence here says that the second angle in a triangle is 6 times as large as the first. second angle 6 times as large as the first. So the first angle, we don't really know anything about the first angle other than it's called the first angle. So what they decided to do there is just call that x, which is what they're explaining in this first sentence here. But the second angle we know a little bit more about. We know that the second angle is 6 times as large as the first. So if the first one was called x and this one is 6 times as big, that's 6x, or 6 times x. Now the second sentence there gets me to what I need to know about the third angle. It says that the third angle is half as large as the second. Half. You know what a half is? Think about the fraction, 1 over 2. Well, that's what half is. It really means dividing by 2. So if I take 6x and chop it into 2, what I have there is 3x. Now what they're showing here, that's just a smidge different. Instead of us just saying divide by 2, they're showing it as half times 6x. But realize that the answer here is exactly the same, 3x. Now, let's tie this all together with what we're studying in this section. We're supposed to find the angle measures here. Remember, those 3 angles, when we put them together, have to make 180 degrees, which is what the triangle sum theorem says. So what we're going to say here is that x plus 6x plus 3x has to go together to make 180, which is what you can see in this line right here. Now, let's make sure we simplify this left side correctly, because if we don't, we're going to have problems. If I give you an x and add to it 6 more x's, how many x's do you have? Hopefully you're saying 7x right now, because you're right. And then I give you 3 more x's. How many x's do you have? You have 10 x's now. So 10x, which is what all that simplifies to, is the same as 180 degrees. I divide by 10 now, right? When I chop out 10, right, I get 18. So x is 18 degrees. Now remember, that's just what x is though. That's not how big each angle is. When I want to find how big each angle is, I'm going to go back over there where I have first, second, and third, and change x into 18 and solve. So the first one is easy, because the first just says x. When I change x to 18, this is just 18. The second says 6 times x. So 6 times 18. Well, 6 times 18, that's going to give me 108, which is what you see here listed in this third box. And then that third angle, which is 3 times x, that's 3 times 18, which is 54. Now, as far as the drawing goes, notice that they never said anything about what the side lengths are. So a lot of you are probably looking at that triangle on the screen and going, well, that looks like it's kind of a small triangle. It is kind of a small triangle. You can draw the side lengths on your triangle to have any lengths you want as long as the angles are 18 and 54 and 108. So start off and draw yourself one of the angles. 108 or 54 or 18, whichever you want. So make your angle. And then, once you get to the end of one of the lines, pick another one of the angles and draw it off of that line you've already generated. You don't actually have to draw the third angle, because by that point you will have drawn 3 sides, and once you close the shape in, the third side is automatically generated. Will the side lengths be the same as what you see on the screen? No, not necessarily. You could have a triangle with side lengths that measures in the meters, but the angles, when I measure them, still have to make 18 and 108 and 54. All right, let's conclude here with the last question, which is, again, more practice with the triangle sum theorem. They're asking us to find B in the right triangle. Well, again, the triangle sum theorem tells us that the angles in the triangle have to add up to make 180. So B, which is the angle I don't know, plus 38, one of the angles that's given to me, plus 90. Now notice again, it does not say 90 on here, but as we talked about earlier, this upside down L does mean 90. So even though it's not written there, it really does mean 90. Those three together have to make 180. Well, if we treat this like an equation, we can put those two things together and make this a little bit shorter then by making it say b plus 128 equals 180. And now you all know exactly what to do because this is a one-step equation I'm solving. So I'm going to solve this by knocking 128 off both sides. And when I do that, that's going to give me b equals, in this case, 52, which is my mystery angle, the missing angle measure, the solution to question number 1. B is 52 degrees.